The deposition system itself consists of an eBeam gun control, an XY sweep which sweeps the beam over top of the crucible in an XY raster type pattern, an ion gauge for measuring high vacuum levels, a TC gauge for measuring the low vacuum levels of both the chamber and of the cryopump body itself, which currently is cold and therefore is at a reasonable vacuum level, as well as the turret source selector that allows you to select which material you'll be depositing. All vacuum valves are operated from the relay controller at the top. The relay controller allows you to open or close valves using solenoid control. The chamber itself consists of a substrate holder on top, which rotates to ensure a uniform deposit. The gun, 6-pocket chemoscal gun, sits at the bottom, and in between there, a shutter allows you to start and stop your deposits. The telescope arrangement allows you to see the actual crucible as it warms up. It's important that you be able to see it so that you can align the electron gun to be right on top of that crucible. The eBeam deposition system works like most. The substrates are loaded on the top and face downwards towards the source. In this particular system, the plate holding the substrates rotates in order to ensure a more uniform deposit. A shutter located between the eBeam gun and the actual substrates allows you to start and stop the deposition. A telescope arrangement here allows you to see the source, since whatever you deposit onto your substrates, you also deposit onto this telescope. So it's a reflection system. You look in the chamber window and you see the reflection off two pieces of glass, the telescope, to be able to view the crucible down here. Substrates in the chamber are mounted on a holder which rotates. This ensures an even deposit so that there are no hot spots where you get higher vapor flows than other spots. Substrates themselves are mounted in these little blanks here. A close-up reveals the telescope through which you look to see and observe the source, and the actual eBeam crucibles located right in there inside the gun. In another view of the gun, the filament underneath produces electrons, which then travel in an arc through this hole inside the magnet system. The magnet system consists of both permanent and electromagnets, which allow the beam to be swept back and forth across the surface of the crucible. Those electrons then travel up in an arc and around, striking your material directly inside that crucible. Assuming they're aligned correctly, the electrons hit the material and heat it up directly and avoid the gun. If you don't get your sweep correct or your high voltage correct, oftentimes the electrons will go where you don't want them, namely into the gun, or into, for example, the hearth underneath, in which case damage will often occur. In this particular gun, 6 pockets allow you to have 6 different materials. The gun rotates the crucible that you're going to use underneath the electron beam as follows. And now a new material has been selected. If you want to go back to a different material, you simply select it and it's rotated into position for you. Remember not to rotate the turret until the material that you were currently depositing is cool. The materials themselves inside the gun are located inside of crucibles which sit inside each pocket of the gun. This helps make changeover of materials as well as cleaning of the gun much easier. The materials themselves can be in a variety of forms. In the case of magnesium fluoride here, we use large chunks of the material which are simply loaded directly into the crucible and then melt when the electron gun, the beam from the electron gun hits it. With the crucibles loaded, we can now lower the chamber and begin rough pumping it before we switch over to high vacuum. Rough pumping is like any other system. You simply select the chamber rough valve, which connects the chamber to the mechanical pump behind it. Within a few minutes, you'll see the TC gauge begin to drop. We rough pump to levels of about 100 millitorr before switching over between the mechanical roughing operation and the actual cryo pump itself. With the chamber now rough to about 100 millitorr, we close the roughing valve and open the gate valve which connects the cryo pump to the chamber. Notice how fast the cryo pump removes residual gases from the chamber. The gauge is now buried, indicating 0, meaning the pressure is below 1 millitorr. Soon we'll be able to use the ion gauge to see the actual pressure inside the chamber. With the TC gauge buried, we can rest assured that the pressure in the chamber is below 1 millitorr. After waiting a few minutes, we can now turn on the ion gauge to see what the actual pressure is inside the chamber. It'll take about 10 to 15 minutes of pumping to get down into the mid-5 region where we can start depositing. After several minutes of pumping, the ion gauge will indicate that the chamber is now ready for the deposition process to begin.